Now continuing with our example of the shape class, which was demonstrated the use of polymorphism, let us extend this to understand what exactly is an interface. Now we had this class shape which had an abstract method called cal_area. Now abstract class can have abstract method as well as non-abstract method, but in our case it does not have any non-abstract method, so it is better to define this class as an interface. So I say interface shape. So interface is like a class, but the main thing for interface is it cannot have any non-abstract method. So all the methods declared within the interface are by default abstract, so we need not even write abstract keyword to this. So an interface has all the methods declared as abstract, and for an interface we do not extend, rather we implement an interface, and this is the only change we need to make. So for all our classes that we were extending, now we implement the interface. Now this is another error which is coming for cal_area. This is because any method that is declared within an interface, as this void cal_area is, this is by default public. Even if we are not writing, this is by default public, and as we had seen during the method overriding condition, that the access modifier in the overriding method cannot be more restrictive than the original method, so we need to write public here and public here too. Earlier it was package, so it was more restrictive than public. So for interface, the only option that we have while overriding is the access modifier has to be public. So rest the entire program remains same, because just as an abstract class you cannot create an object for an interface, but we are nowhere in our program creating any object for the interface shape. So the program compiles perfectly and runs perfectly. So it is giving the same output. So this the same thing we have implemented with the abstract class, and now we have implemented the same within interface. So we'll go further with the interface. Now I'll have a class called intershow. I can create an interface I1 and declare a method show here. I can declare another interface I2 and declare a method show1 here. And our class intershow, it can implement both the interfaces at the same time. So this is where multiple inheritance comes in Java. We cannot extend multiple classes, but we can implement multiple interfaces. Now when we implement any interface, all these methods from the interface, they get by inheritance, they are into the class intershow, but as they are abstract, so this class has to be declared abstract in order to compile the program. This is what error we are getting. So it says it must implement the abstract method show, it must implement the abstract method show1. So I can just add these implemented methods, and you can give any default implementation for this. So for any class to properly implement an interface, it must override all the methods of the interface and give them some body to, in order for the class to be meaningful. Otherwise the class would have to be declared abstract, and we'll need further another class which would extend this class so as to make it meaningful, or to make it more purposeful. So this is how the circle completes. Any class can implement any number of interfaces, and the only condition is it will have to implement all the methods. It will have to override all the methods of the interface and provide them appropriate body. So now class intershow can be used by creating its object, and you can call any of the methods of the class. Now another is that interface can extend another interface. So now instead of the class implementing both the interfaces, it can only implement one interface, which itself is extending another interface. So interface can extend another interface, and the similar rules apply for inheritance for interfaces as it was for classes. So class implements an interface, whereas interface extends an interface. So last we have what about the variables in an interface. So let me create a DOS program and create an interface. Suppose I say interface var. Now why would we declare any variable within an interface? Now what would be the purpose to declare an interface, variables within an interface? Normally we will declare only such variables which we need to use as a constant value in our class, and that is the type of variables we'll declare within an instance. Normally we will not create variables of this kind in an interface, because such variables we can even declare within a class which will be implementing the interface. So I'll, for reference, like I can create a variable called pi and give it a value of 3.14f that we commonly use. So this is the kind of variables that is recommended to be declared for interfaces, which we'll be using as such in our class. Now I haven't added any modifier to this variable, but let us see what modifiers are added for this variable. I'll just run the tool java p -c, and then I have made the interface var. So just see, we have not written anything public, any static or final to this float pi. So what it shows is any variable that you declare within a interface is by default final, it is by default static, it is by default public. So for public it is very simple, because interface in itself has no meaning, it has to be implemented by some class. So we need all access to the various things defined within the interface, so we made it public. Now final, as I have already discussed, that variables declared within an interface are those variables which we need as such. So by declaring this as final, this improves the efficiency of the compiler, because it did not check it time and again whether the value is changing or not. So we declare this as final, and now any final variable, to make it instance, will mean that every object of the class that you create will carry a copy of this variable. So having multiple copies of this variable which is already final will lead to a lot of loss of memory that we don't require. So we declare this as a static variable. So this is more or less a constant value that we declare within an interface. So we can check up what we are saying. So I declare an variable, we are extending I2, I1, can even declare directly here. I say float pi is equal to 3.14 f. Now to check whether this is really final, I'll now to check whether this is a static, I can directly try to manipulate this, or I can I am directly printing the value of the variable pi because this is static. Had it been instance, we could not have been able to print the value directly. So this gives you 3.14. And now if I try to change the value of pi to 4.14f, so this generates an error because this is final. So any variable defined within an interface is by default public, it is by default final, it is by default static. So this is how interfaces work, and how multiple inheritance works in Java. It is through the interfaces. Interfaces can extend interfaces, class can implement any number of interfaces, and the variables declared within interfaces are by default public, they are by default static, and they are by default final.